Hi, I'm Pravar, and I'm a rising junior at Thomas Jefferson High School. And this is my mini tank. Now, I chose this project because I'm an aspiring car designer and an automotive engineer, and I really like everything on the road. Cars, motorcycles, and tanks, while not on the road, are still pretty cool. They've got two motors, tank tracks, and this one especially I chose because it has a suite of sensors here, photoresistors, ultrasonic, and an IR receiver. And I thought that would be really cool to work on to learn how they're used and the logic behind coding them and their applications. Um, while the tank by itself was incredibly cool, I decided to make it more useful by adding a robotic arm on the back. Now, both of them are controlled by the IR remote. It can go around on the floor, pick things up, bring them back to me. So to turn it on, I actually have two Arduinos. One Arduino Uno on the tank, which is bigger and more capable since it has to run motors, servos, and sensors. Just hit a switch and it's on. For the arm, there's actually an Arduino Nano. All that needs to do is run 4 servos, so it doesn't require much power or much processing power. Yeah. So the tank actually has an LED screen on the front. It's an 8x16 panel, and it shows all the movement. So if I hit the forward button, you should see an arrow. Same thing for the back. I'm restricting movement because I don't want it to die and fall off. Turning, same thing, arrows. And every time it stops, big stop letters. The arm is controlled by the same remote. It can pivot on its base using a servo. It can lean forward. It uses 2 servos to pivot and lean forward. And the claw can also open and close, closing, opening. And all of these servos I can control with this remote and stop wherever I want them to, exactly where they are, or keep it going. So my process of building this was actually pretty straightforward. I started by assembling the chassis of the tank. It consists of 3 metal plates, which are all bolted together, and they're also connected to the motors, and the motors are connected to the wheels. And then I got the tank tracks on, and then went the standoffs on top of the metal plate that is home to the acrylic plate, which houses all of the electronic components. So the sensors, the Arduino, all of the brains. After that, I started getting the movement working. So at this stage, I had the tank moving forward, back, turning left and right, using both this remote and an app on my phone, which works using Bluetooth. After that, I wanted to get the sensors working. Now, this was one of the most interesting and fun parts because I've got 2 photoresistors and an ultrasonic sensor, and there's many things you can do with that. This tank, I got it to do object avoidance. So on the floor, it can go around, detect an object, and go around it. Object following, so I can have it follow my hand. And light following. That it uses the photoresistors. Photoresistors are essentially light sensors. It can tell how bright it is, how bright the light is, and well, what if light is shining on it. After that, it was time to make it more useful. So I built up the robotic arm, and actually one of the biggest challenges I faced was while building the robotic arm. Once it was done, I realized that the robotic arm was controlled by a joystick controller. Now this controller was connected to the Arduino with a wire. It was an 8 or 9 inch long wire, and the tank it's supposed to move around and pick things up, but it's pretty useless if I'm right next to it with a controller controlling it, making it do things. So I had to get it working with the IR remote, and this meant I had to learn a lot about how to use servo libraries, how to get the servos moving, how to get them to stop where I want it to, and also I had to learn how the Arduino understands the signals coming from my remote and how I can get the code to understand that and map all the functions to the respective tasks. Another problem that I faced was while doing this coding part was the servos that came with the original arm. So these 3 main servos that do the heavy lifting, these servos were very weak. They were rated for 9 grams, and they didn't pick anything up. I was using my AirPods as a reference, and AirPods aren't very heavy. It couldn't even pick that up. So I replaced it with 7-kilogram servos. Pretty big upgrade. So now it can pick up my AirPods. It can almost pick up my phone. Definitely pick up this remote. And yeah, now it's pretty capable. Looking forward, I'm thinking of adding a camera to the front so that in case if it goes behind an object like a couch or a table or something where I can't see it, the camera can live stream video to my phone or laptop, and that way I have eyes on it and I can make it do things even when I can't directly see it. So my time here at Bluestamp has been incredibly rewarding. I've learned a lot about Arduino programming using C++. I've learned about the logic behind programming. I've learned how to put things together, how to 3D print parts that are actually a pretty exact fit for whatever I need it, how to solve problems, and overall just how to start with an idea, get the product, and in a couple of weeks just work through all the problems, work through all the little annoying parts, and get it to where I wanted to get my vision to reality. Thank you.